Right, so I am trying to make a long rod. This is for when you want the spike to stand up above the planting, and when you, so it will sit like that above the ground. There's a little slot in the side for the cable to come through. It's a hollow tube. So that's the idea, is that if you've got some planting that's quite dense low down, this will get your spike above it. So this is a 400mm piece. It's just what I agreed with the designer. Funnily enough, I was also asked to quote some pathway lights a little while ago, and this design is basically utilising the same part. So the part's kind of universal, and you know, in manufacturing, what you want to do is try and make your parts as universal as possible. It means that they get more use, and it's simpler in their design and construction and easier to produce. So anyway, this is the rod. I've got to make a couple of changes. So this slot on here is a bit small. The cable does fit through it, but it's a little bit tight. So I've changed on the machine. Sorry, I don't have the lights on. I've changed on the machine this 8mm end mill now. It was a 6mm end mill, now it's an 8mm end mill. So I'm going to give it another machine, another go. See, we're trying to avoid that light. Look at that. Terrible, isn't it? I think the Unilight has died. Yeah, it needs a charge. So we're going to try and machine this this 10mm tube, and we'll see how we go and see whether or not we can build this. And hopefully, so this is Friday late afternoon at the moment. We'll get these machined today, but won't get them powder coated today, I don't think. So hopefully on Monday I can get them powder coated and get them over. So here we go, going into a bar push, positioning it into the correct position, which is our 0, and then starting the program. Drilling. Looks like I accidentally knocked the coolant slightly off. Whoop. Tap. Now we're going to do our milling, or a slot. So I mean, the machine's running as fast as it can run. It's quite slow, isn't it, really? I mean, it's fine, but, you know, like, it's fine for what I do. I mean, the feed rates for doing stuff could be quicker for sure, but what I mean is, like, the rapids etc. are as fast as they are running, the tool changes as fast as it will run. So now it's going to unclamp, and that's just going to push straight through, so it's done automatically. It's kind of useful. Total, that cycle takes 1 minute and 13 seconds. So continuing on with part 2, what I want to talk about is the top of this light. So this is essentially the top. So as you can see, there's a slot here. Now in an ideal world, what we'd have is this top screwed tightly to the base, because obviously how are we going to get watertight? Well, the only way is we're going to have it screwed fully together with the O-ring on the bottom. The problem is lining up the threads, and I said it in the last video about trying to work out how we line up the threads. So for instance, the ball joint that's here in the bottom is screwed in all the way, and the top screwed in all the way. Now that slot that's there should line up with the slot in here, and obviously it doesn't. So, you know, the only way to get it to line up is to loosen the whole top, which is not what we want to do. So what I'm going to do is I'm going to machine a new part, or some new parts, to try and get this resolved. Essentially we're going to work this round an O-ring situation. So let me explain. I just machined this top. So what this is basically the same as the top that's been slotted, but the difference being that obviously it hasn't got the slotted top on it. What we're going to do is we're going to machine that separately. Our seals are all going to be on this side, so the top that goes on isn't going to have a seal that affects the IP rating of the fitting, so it'll still be IP68. All will happen is the slotted top section will just go on top of this and sit on the O-ring, which means that when it sits on the O-ring, it means we'll be able to rotate that top in any direction we want without changing where the thread is on here. I thought that was, hopefully this works out as a solution. I'm sure it will do. So when I'm machining new parts, I tend to go through quite a lot of scrap parts. I'm getting better and better at it actually, so it's not too many. But that was our original head, as you know. Then what I did is I broke that program down into two new programs. One to do a top and one to do a bottom. So I started with the head that I made here, which didn't have its hole through. I checked that dimensionally it was correct on the bottom, and then I made sure that we could fit an O-ring on this outside edge. Following on from that, I did another part again just to correct dimensions, etc. And then finally I did one where we actually got a hole through because the lens actually sits through this edge. And then I started on the top sections and ended up doing 3 parts for that as well before getting a full final part. So the only difference really with these, other than obviously the height of this one, is that the inner interior dimensions have been adjusted just to fit on top of the O-ring. So I'm going to pull out the fitting that I've got underwater at the moment. I'm just testing just to show you kind of what that looks like together. So here is our the actual fitting with so it's got a spike bottom on it, and then it's got the top that was adjusted finally for the O-ring. You can see there's a lens in here so it's just an acrylic lens that's machined. That provides our seal for the fitting, and then this O-ring allows us to rotate the top. So if I insert this top back on, it's quite tight, but it's meant to be tight. There you go. So that now with the O-ring means we can just rotate that top round as we want to, which is quite useful, because then if it's not facing in the correct direction, we rotate it without having to unscrew anything here. Means we can keep our seal intact and still get the light output that we want in exactly the position we want. So yeah, I mean, that's the new final adjustment I'm making to this fitting. I may test some optics, etc. in future, to kind of see whether or not I can adjust any of the light output. But I mean, if I'm honest, I'm really happy with how the light comes out. It's just now really looking at whether or not having this raw or anodized really is going to make a lot of difference. So we're going to experiment with doing both of those, just because normally when we anodize black, and it would make the interior of this portion inside here black, which would affect how the light reflects on the inside. How it's going to affect it, yet to determine, but we'll see how it comes out.